everyone. I'm Shaylin, and today I wanted to talk about the WaveFunction collapse algorithm and how it's used to procedurally generate content in video games. So what is the WaveFunction collapse algorithm? It is sorry about that. It is a constraint-solving algorithm used to generate content such as images, levels, maps, and 3D structures, and it was created by Maxim Guman in 2016. The algorithm is inspired by principles of quantum mechanics, specifically how particles exist in superposition, collapsing from a state of uncertainty into a definite state when observed. Similarly, the WaveFunction collapse algorithm reduces uncertainty in a grid until a valid configuration emerges. But wow, that sounded like a mouthful. But I'm sure the next few slides will explain all of that. Sorry about that. But first, I wanted to get to defining adjacencies. So when it comes to tile sets in 2D, for example, we have this road. We see that when we compare it to this example over here, the road can only connect on the top and to the right of it because it has to make sense in a map. And this is something that we would define manually or through a sample input. I want to explain the collapsing states to you with a demo. So if we look at this is a 2D grid. As you can see, there are big tiles, and within them there's multiple possible states. So this is what is meant by having all possible states exist in every cell at the same time. So if we look here, if I, for example, collapse this state with a torch, as you can see, some of the other cells have lost some of their possible states. What this is constraint propagation. It's basically saying that if I place a torch here, obviously above the torch, you couldn't place a floor or a tree. So through this method, through constraint propagation and collapsing, we will be able to generate a well-defined map by the end. This I can solve. As you see, through constraint propagation and collapsing, it's able to have created a pretty good map without any visual issues. So I wanted to talk about how I took advantage of this algorithm for 3D procedural generation in Minecraft. So this is my honors research project, the poster from last year. I basically evaluated different cell selection strategies in Minecraft with the WaveFunction collapse. So I didn't touch on this earlier, but when we do something like this, normally I just selected a cell by random and collapsed it, but in an actual algorithm, it would collapse cells with the lowest entropy first. And what that means is cells with the lowest amount of possible cells, so cells with the highest certainty. So for example, this cell would probably be collapsed next because it doesn't have multiple states that can still fulfill. So I wanted to try making newer cell selection strategies. I created a high priority cell selection strategy, which enforces a bottom-up approach that tries to prioritize collapsing cells at lower Y coordinates. I had a center-based approach, which prioritized cells based off their distance from the grid center. And I also used constrained random walk to simulate organic growth patterns. What constrained random walk is basically when you take steps into a random direction, but having certain rules to guide you from straying off too far. So here's my pipeline overview. I manually constructed tiles. I manually defined tile adjacencies. I did want to use pattern extraction, but it is quite difficult in 3 dimensions. I then applied a cell selection strategy, run the WaveFunction collapse algorithm, and then generated a valid 3-dimensional tile with a correct configuration to build structurally coherent tiles in Minecraft. Here's a quick demo video. I wanted to bring the actual live code to you, but I thought it was a bad idea to download Minecraft on my work computer. Sure. So I thought it was just very cool what this algorithm was able to generate. Here's some other images of some buildings that I was able to generate in Minecraft with different interiors. So in conclusion, the WaveFunction collapse algorithm offers a powerful way to create coherent, diverse, and immersive worlds with minimal input. From 2D indie games to 3D complex structures in sandboxes like Minecraft, we know that the generated content will feel well structured. Beyond gaming, sorry about that. Procedural generation algorithms such as WaveFunction collapse extend to areas such as movies for creating landscapes, and also as well as training reinforcement learning agents where it can generate dynamic, procedurally generated environments that can help with generalization and robust learning. As the demand for adaptive intelligent systems grow, WaveFunction collapse's versatility makes it a great tool for game development, AI training, and generative design across industries. Thank you.